All right, let's take a look at problem number 4 here. Our goal is to verify that triangle RST is similar to triangle XYZ. Okay. We also want to find the scale factor between these two triangles. um, so if we take a look at the information we have, we just have a bunch of side lengths, right? Let's draw a picture first of all. Okay. So if I look at triangle RST, I see the measurements are 12, 15, 24. If I look at the triangle XYZ, I see the measurements are all bigger, 28, 35, and 56. Okay, so I'm just going to make a little sketch here. This is going to be triangle RST. It's not drawn to scale. And then this is going to be triangle XYZ. Again, not drawn to scale. Okay. All right, so one of our theorems, let's see if I can find it here, is the side-side-side similarity theorem, right? What we need to do is we need to find the ratio of the let's just call it the blue sides, the green sides, and the red sides, right? Or just find the ratio of the long sides, the short sides, and the remaining side, and just verify that those three ratios all come out to the same number. All right, so we have right here 12 and 28. Those are both the short sides from the two triangles. So we can just create that ratio, 12 over 28. Okay, and that equals 0.4, about 0.43. Okay. Next we can take a look at those two lengths. Those are both the longest sides of the two triangles. So we can do 24 over 56, right? We'll do this ratio. Okay, we get the same result, 0.43. And then we'll take a look at the remaining side, and we'll look at the ratio of those ones. 15 to 35. Okay, and it is the same ratio, it's 0.43. Okay, so since we've found the ratio of the short side, which was red, the ratio of the long side, which was blue, and the ratio of the remaining side, which is green, and that ratio is the same for all three sides, that basically proves, okay, by the side-side-side similarity theorem, okay, that the two triangles are similar. So triangle RST is similar to triangle XYZ by the side-side-side similarity theorem. Right, all three pairs of sides form the same ratio. Okay. All right, so now the second part of the question says find the scale factor of triangle RST to triangle XYZ. Okay, so we want to find the scale factor, okay, that takes us from the small triangle, the small measurements, up to the big measurements. Okay. Well, actually, all the work that we've done was actually the reverse scale factor, right? So we found the scale factor to go from the big measurements to the small measurements. Right? If you take any of the big measurements, multiply it by 0.43, then you will get the smaller measurements. Okay, so if we want to find the scale factor to go from small to big, we just have to reverse all these fractions. Okay, so 28 over 12, or 35 over 15, or 56 over 24. Okay, any one of those should give us the scale factor going from small to big. Okay, so if you compute any one of those fractions, you get 2.3 repeating. Okay, so the scale factor that takes us from the small measurements of the left triangle to the large measurements of the right triangle is 2.3 repeating.